Keep ready. So it will be very interesting class. I already heard brothers told already they studied, but I don't know how much you studied. Now you can make it. So this is the last concept in this chapter. So all of you keep ready. Decay and growth. Growth and decay. Growth and decay of current. So in which circuit, everybody? In LR circuit. What do you mean by LR? L means what? Inductor. R means what? Resistor. Okay. So growth and decay of current in LR circuit. Just for a while, we'll discuss what is inductance. So which we already studied. And then we'll come back to our class. Okay. So hope you all are there. So let's start now. So already this video I've already shown you, and once again we are making it so that just you can be brush up the things. So it will be
connected to a bulb via a switch.
You can see that. Directly a battery is connected to the bulb. You can see that as soon as if I on it, the bulb will glow with the maximum brightness. Am I right or wrong? Everybody, please respond. All of you.
Yes, sir.
Yes, sir. So if I introduce a material, call it as inductor, so then what is happening? It will take some time to reach the current to the maximum. Same way when I off the switch also, it will take some time to fall in current also to zero. Is it right or wrong? 0 to maximum, maximum to 0. Like when I on, growth of the current, when I off, fall of the current. So there will be a time lapse. Means there is a time between the 0 to maximum, maximum to 0. That is because of the instrument what we are using here. What is that instrument, everybody?
Close the switch.
Yes, please. That is only called as inductance. Am I right or wrong, guys? Please respond. So we all know that, and as well as according to the Lenz's law, so more faster the growth in current, the opposing current in induced EMF also, it will be more opposes or less opposes, everyone?
More opposite.
More opposes. If the change in current is slow, then opposing also what? Induced EMF in inductor also low. So do you all agree with that point? Do you all remember that point? I want answer from everybody. Mr. Monesh, Manu and Samya, Mr. Kevin, please respond. That is what. So if you remember that, then today's class is very easy.
The bulb glows. Open, bulb doesn't glow. Close, bulb glows. No surprise over there. But now let's attach a coil wrapped around some metal in series with the bulb.
That is only which we used to call it as. What does that call it as? Inductor. So inductor and bulb is actually what? Resistor. Bulb is definitely have resistance. Am I right or wrong? Please respond. Yes. So if I introduce the inductor, what is happening? Current is started rotating, and we all know that. So bulb, it won't glow to the maximum at the instant where t is equals to 0. Where t is equals to 0, before current becomes maximum. But now current become what? T equals to 0, current is also becomes what? 0. Is it right or wrong? Please respond. Then the current is started increasing. Then this inductor will turn up into what? Everyone. This inductor will turn up into voltage. Is it right or wrong? Please, induced EMF. EMF will make it. So when the current is passing in this one, so the induced EMF will opposite. So it will act, induced EMF will act opposite to that. Yes or no, guys? Please respond, guys. So more faster the current rising here, more the opposition will be. That is only Lenz's law, which we already studied. Is it right, guys? Please respond. Same way, the current slowly rising, then induced opposition will be less or more. Everyone. Rose, change in either increasing or decreasing. Change is more, then opposition also more. If the change is slow, then the opposition also slow. That is only we studied. Is it right? Will you all agree with me? Yes or no?
Yes, sir.
Yes. So that is what. So just a minute, or all of you observe.
Bulb and see what happens. Ready? 3, 2, 1, close. Ooh. Now we see the bulb takes some time to glow. Why is that?
Now, one more question.
Well,
When the current reaches to maximum, does it having any opposition force? That is what, due to the inductance, everyone? Once the currents will reach to maximum? No. So do you all understand, everyone? When the current is 0 also, inductor will be breakdown. No use. When t equals to 0. When t equals to infinity, where the current will reach us to what? Am I audible, everybody? Where current will reach us to what? Maximum. Then also, what is the inductance? 0. Am I right or wrong? The role of the inductance is 0. So where is the inductance used? Only when more than 0, less than maximum. Is it right or wrong? Please respond, everybody. Yes, guys?
Yes, sir.
That is what. Understand, Rudresh? That is what.
Let's find out.
Yes, sir.
Wait, did you see that? Seriously, what is happening? So with the coil in series, we saw that when we close the switch, the bulb takes some time to glow to its full brightness. From this, we can infer that the current takes some time to grow to its max value. The value.
Please, everybody attend till last. This will be very interesting and good formulas also very important. That's why. So please, if you have any doubt also, small doubt also ask me so that we'll proceed.
Value given by
Except
Ohm's
I'm
law,
going to draw now.
maybe 1 ampere. Let's say that's the maximum value, which means the coil is for some reason delaying it, slowing the rise of the current. But why is it doing that? Well, let's investigate. If you pause the animation over here, we know that there is some current running in the circuit. It's not maximum value yet, but there is some current, and that current is of course going through the coil. And we've seen when we have current circulating through some coil, it generates a magnetic field. We've seen this enough number of times now. Now what's interesting over here is that this current is increasing. Remember, we are not at the max value. We have paused the animation. The current is going to increase, which means the magnetic field that is produced over here also tends to increase. Ooh, this means the flux is increasing. And we know from Faraday's law that whenever there is a change in the flux, the coil will induce an EMF trying to oppose that change. So over here in this coil, there will be an EMF induced opposing that change in flux.
So now
Okay,
this opposition,
that's a lot to take
this
in. So let's
opposition will be depends on what? How much fastly, how much forcefully it will oppose. It is depends on one thing. What is that, everybody? It is depends on how much fastly the rise in current. Am I right or wrong, guys? Everyone?
No, sir.
Yes. So the more faster the rise in current, more faster the EMF is induced, more faster it will be fall down. Am I right or wrong? Opposition also increases. Yes or no, guys? Please
Yes, sir.
respond. That is what. So that is what, because of Faraday's laws and Lenz's laws, and we all discussed even last class, we derived, you can see that, that mutual inductance we discussed in a two coaxial solenoids. Do you remember? Last Friday, Saturday, I taught you. Two
Yes, sir.
coaxial solenoids we discussed. Same way inductance of two concentric coils, and same way you might be remember self-induced of a long solenoid we discussed, and mutual inductance also we discussed. Am I right, guys? Please respond, everybody. So if you all notice it here, so if there was no inductor, then what is happening? Bulb is glowing what? Very instantly. Yes or no, guys? Please respond. So if there is no inductor, as soon as the switch is on, bulb will go to maximum or minimum? Everyone, maximum. If I close the switch, the current will become zero immediately. Yes or no, guys? Please respond. If there is no inductor, no answer. Everyone. Before the
Yes, sir.
case, if there is no inductor, what is happening here? There is no inductor before. As soon as if I on the
Instant.
switch,
bulb
at
glows.
that instant,
Open,
current is becoming maximum. If I open the switch,
bulb
current is
doesn't
becoming
glow.
zero.
Close, bulb glows. No surprise over there.
That is what.
That's why inductance is
Understand?
often called
Everybody clear?
electromagnetics.
Please respond.
To be more precise, we should
Yes,
call
sir.
it self-inductance
Self-inductance.
because the changing current and the opposition, they're both happening in the same coil. So the coil is sort of kind of like opposing itself. And that's why it's called self-inductance. So more inductance means more ability to resist the changes in the current. So it's kind of like an inertia. In fact, that's why inductance is often called electrical inertia, resistance to change. But change of what? Change of current. Now, before we get back to our story, let's think about how much EMF or how much voltage is this coil inducing due to the changes in the current. We can figure that out using Faraday's law. Faraday's law says that the induced EMF in any coil equals...
Anybody can tell me the formula? What is the Faraday's law formula? Induced EMF is
D
equal
by
to... Yes?
pi by dt.
N
Minus
phi
d pi
over dt,
d pi by...
where phi represents the magnetic flux.
Sir,
You can
no,
call it
magnetic
d
flux,
phi b over
d
dt.
pi b
This
by
basically
dt.
says that
Sir,
the
no, guys,
induced EMF
is equals to
depends upon how
something.
quickly the
Anybody can
flux
tell?
changes. If the flux changes very quickly,
And what is n by? For one round, d pi b by dt. Now n indicating what? Number of turns. Understand? That is
a
it.
very high EMF is induced, and it more in a coil equal to
Is
negative
equals to what? Minus
di
of L into
over dt.
di by,
We're basically
by
saying
dt.
the flux is changing because the current is changing, right? And it's proportional, so there should be some proportionality constant.
That constant only which represent with something. Anybody remember? L.
L is
So that is only
L.
call it as a what? Self
Conductance.
Inductance. Understanding? Now, do you all remember what is inductance? I want response. Everybody. Clear, guys?
Yes, sir.
Yes. So now from here we'll continue now. So now growth and decay of current in LR circuit. So inductors and resistor. So now first we'll discuss the derivation for growth. All of you observe is a very simple one, but it's a very important one. So I'm taking EMF who is having E. So a switch is S1. Let me take, okay, open switch now. So now I'm using an inductor. I'm using an inductor. So now growth, guys, it is. So growth means inductor will decrease or oppose. Current is increasing. So inductance, induced EMF will opposes or it will supports. Everybody. It will speak loudly. Induced current will oppose or support, guys. Are yaar, growth now. Growth in current. So current is growing now. I is growing. So I is growing. So induced EMF will opposes or supports, everybody. It will oppose.
Support.
Understanding? Support. Growth means increasing time, it will oppose current. Always it will oppose us. Faraday's law. Yes or no, guys? Nobody says. All of you. So when there is a rise in current, so induced EMF will oppose it or support it. It will oppose it. Do you understand? If there is a fall in current, then induced current will be supported. Yes or no? I want answer from you people. Yes, guys. So that is what. That is what we are studying current, right? It is always opposes. Just now I said. What is that saying? It will oppose us when there is a growth in current. It will oppose us when there is a fall in current. It will support it. Yes or no? Please respond. Nobody answers. Yes, brothers.
Yes, sir. Yes, sir.
Once again.
Yes, sir.
Yeah, please.
And that constant we fluctuates very quickly. A very high EMF is induced on flux.
What is actually
Inertia,
oppose the
resistance to
change
change, and the
Once again, you listen. That's
change. And this ability to resist changing currents, current use an EMF and will try to increase it. Remember, the coil has no problems with the current itself. Once the current reaches the maximum value, the current that always tends to oppose.
Listen from here, everyone.
Because of that changing current, because current is producing magnetic field and there is a magnetic flux, there is a changing flux over here. The flux is changing. And we know from Faraday's law that that changing flux causes the coil to produce or induce an EMF, and that EMF always tends to oppose the change.
That is what. Do you understand? So now there is increase in current. So it will oppose us or supports, everybody. It will oppose. Am I right or wrong? Opposite it is. If there is a fall in current, then the induced EMF will what? Support it or oppose it? It will always act opposite to that. If there is a growth in current in the circuit, then the induced EMF will oppose the change. If there is a fall in current, opposite to that. What is opposite? If there is a decrease in current, it won't like to decrease it. So it will support it or it will oppose it. Please respond. Oppose. Others also should respond. Do you all understand, everyone? If there is an increase in current, the inductor don't want to increase so that it will oppose or supports. Everybody. Always it will acting opposite to that. If there is a growth, opposite to decreases. If there is a fall, opposite to that, it will supports. Do you all understand what I am saying? All of you?
Yes, sir.
Yes, guys. So what is the induced EMF? It will always don't want to change. Don't want to increase, don't want to decrease. If there is an increase, it will oppose to decrease it. If there is a decrease in current, it will oppose to increase the current. Do you understand, everyone, what I am saying? I want answer from everybody. Clear, everyone? Yes?
Yes, sir.
So that is what induced EMF. So induced EMF always opposes the change in magnetic flux. Change in magnetic flux means what? Change in current. What current? The current which is induced, the current which is rising in the circuit. Do you all understand? Please respond, everybody. That is what which we used to call it as self-induction. Yes or no? So what is the formula we studied? Faraday's law. Everyone, just now we studied. So Faraday's law will says that what is the induced current? In the induced flux is equals to, everyone. Formula, please. Self-inductance formula. Induced EMF from that. Minus N into. Nobody answers. So induced EMF which is equals to what, everybody? Minus n number of turns into d pi b by dt, which is equals to change in flux equals to what? Change in flux equals to change in current. Am I right or wrong? Please respond. So that is what? Di by dt, and there must be a constant. So proportionality, that is what? What is that constant which we used to call it as? Everybody. Self? No answer. What does that L means? Self-inductance. Yes or no, guys? I want to answer. Yes, please. So now this is a growth. It is a growth. So now induced EMF will act opposite to that or same direction. Support it. Everybody. Now current is inducing. Sorry, current is coming in this direction. There is a growth in current, positive to negative. So that now induced EMF will act same direction or opposite direction. Everybody. Imagine S1 is just closed. S1 is what? Everybody? Just closed. Do you understand, Amma? Everyone should respond. So current is inducing here. So it will act same direction, opposite. Opposes the change because now there is a growth in current. So induced EMF will try to decrease it or try to increase it, everyone. Just now again, same question I'm asking. To try to decrease it. Yes or no, guys? Please respond. Rudresh, Pradosh, that is what. So let us imagine now, if S1 is closed, S1 is closed where T is equals to 0. Then what about the current in the circuit? I is equals to also what? At that instant, what will happen? Please respond. I is equals to also 0. Yes or no, guys?
0.
0. Now, if suppose there is no inductor, what will happen? If there is no inductor, there was no inductor, so that the current will becomes what? Yes, please.
Sir, you are sharing screen or
Oh,
not,
I'm
sir?
sharing my screen. It is not there. Okay, sorry for that. You should tell me correct. I forgot it. Yeah, now is it okay? Is it visible?
Yes, sir.
Yeah. So now what is happening? If the S1 is just closed, sorry for that, you have to ask me. So now there is a growth in the current. If there is a growth in the current, so the induced EMF will try to decrease it, opposite, always acting opposes the change. So if there is an increasing is the change. So induced EMF will opposes, means it will try to decrease or increase. It will try to decrease it. So it will act opposite to that. Yes or no? Please respond, everybody. Yes,
Yes,
guys.
sir.
So that is the direction of induced EMF. So now, when S1 is closed, where T equals to 0, at that instant, current also in the circuit is how much? At that, where T equals to 0. Everybody. Yes, please. 0 only. Yes or no? So if suppose, if there were no inductor, then the understanding, then instantly, at that instantly, I will becomes what? First starting we say, without inductor, I will becomes what? I reaches to what? Everybody. Maximum value. All of you understand? So immediately I will reaches to what? Narayan? Immediately I will reaches to maximum value. Now all of you understand? Everyone, please respond. Clear, Mr. Monish? That is what. So now inductor, it will opposes the current or always it will act what? According to Faraday's laws, it will always opposes the change. Now here change is what? Growth or decay? Growth means increasing, decay means decreasing. So it is a growth. So inductor always opposes the current. So what is the maximum current formula? What is the maximum? I is equals to I initial, I naught is equals to how much it is? Voltage divided by resistance. That is what E by R. 10th class we studied I is equals to, you all remember, resistance is equals to V by R. Then, V by I. So I is equals to what? V by Ohm's law. Ohm's law, what it will say is R is equals to V by I. I is equals to V by R. V means here what? E only. Yes or no, guys? EMF. Battery. Correct or not? Yes. So if there is an inductor, so inductor we all knows that always it will opposes the current. So for that, what is happening? Thus, it will take instantly, it will becomes maximum or it will take some time. Takes, please respond. Time for current to grow. Okay, or to, that is what? To grow to the maximum, it will take some time. When there is an inductor. If there is no inductor, instantly the current will reaches to what? Maximum. All of you clear, everyone? Yes or no? Please respond. That is what. So to become a maximum, to grow, it will take some time. That is what will take infinity. So once it will reaches to the infinity, let me take in initial case, when T is equals to 0, then I is equals to also what? Speak loudly. I is equals to also 0. So this is our initial stage. So now at that initial stage, current is 0 means it is like, it's become like a what? It will behave like a what? At that instant, open circuit or closed circuit. It will behave like a what? Open circuit. Do you understanding? Current is zero, guys. No current is passing. So means at that instant of time, inductor breaks. Do you understand, everybody? Inductor what? Breaks. Like you can see that. So inductor breaks so that current will become what? Zero. T equals to also zero. Where? Initial state. So when time is keep on increasing, time becomes infinity. So time becomes infinity, I become I naught. That is only which way is to call it as maximum. Yes or no, guys? Please respond. So I become I naught after certain time. Maximum brightness occurs. Once the bulb will glow maximum, is there any importance of inductor? That's my question to you guys. Once the bulb will reach the maximum, is there any importance of inductor? Everyone, inductor will become no role. Yes or no? That is what.
Yes, sir.
Once it will attains the maximum, that is a condition which we used to call Sturm. What is that call it as? Everybody. Yes. Maximum current, already bulb is glowing maximum. Then what will happen? It will attain the what?
Ready.
Steady state. So in this situation where the current reaches to maximum, now inductors having any value, everybody? Yes. What is the role of the inductor?
No, sir.
Role will be zero. So there is no role. So only inductor having importance, it will becomes up to where? Yes, please. Do you all understand, everyone? So once the current will become maximum, the inductors no opposing, because already it will reach us to what? Maximum. Is it okay, guys? Please respond, everybody. All of you clear? So inductor has only value when there is from 0 to infinity. Time is t is equals to 0 to t is equals to infinity. Do you all understand, everybody? Please respond, guys. Yes. Nobody answers.
Yes, sir.
Yeah. So that is what you should understand it. So now, in this situation, there is no rule of, there is no role of inductor. Means the circuit will become like without inductor. Will you all agree with me? Yes, Pradeep, Mr. Narayan, Rudresh. So once the
Yes,
current
sir.
will become maximum, by the time inductor is there or not, doesn't matter, because already bulb is glowing with what? Maximum?
Maximum.
Maximum brightness. That is what you should understand it. Now are you clear? Everybody? Yes?
Yes.
So please remember that. So this is what you should understand. Okay?
Yes,
So
sir. Yes.
anybody you can remember. So all of you. So when there is a maximum current, once the circuit reaches to the maximum, then there is no role of inductor. Means circuit is behaves like that. When t equals to 0 also, the inductor breaks. Means no, because current is 0. So by the time inductor breaks behaves like a breaks, there is no use of inductor there also. I is equals to 0, t equals to 0. When t equals to infinity, I become maximum, means constant, steady state. In this case, the circuit feels like there is no inductor. There is no role of inductor by that time. So only inductor is having some role where at some time, where t is equals to t. Do you all understand, everybody? Yes, please. Where, so t is varies from 0 to where? What is the range of time? 0 to t equals to 0, t equals to, speak guys, t equals to infinity. Yes or no? So when t equals to t, so I is equals to what? I is equals to 0, or I is equals to maximum, or I is equals to I. When t equals to t, speak loudly, guys. You should speak, it is good. I is equals to I. Yes or no, guys? So I is also varies from 0 to where? 0 to I naught. I naught means what is that? I maximum. Yes or no? I want answer.
Yes, sir.
Yes, guys. So the range of current, range of time, range of current. So at that time, you can see where at time t equals to t, time is not infinity, time t equals to t. What does it mean? So current also, induced current also, sorry, the current in the circuit is also I. Yes or no, guys? Speak, everyone. Don't be like
Yes,
this.
sir.
So at that time, we are going to find the formula, because maximum also no use, minimum also no use. So let me consider now where a positive negative E. Okay. So now the induced EMF, I am assuming as a dotted lines, because it is not a minimum, it is not a maximum, in between that. So it will reach us to intermediate stage where T is equals to T. So induced EMF is L. So okay, little bit dotted lines you can draw. So now if you all notice it, all of you, so induced current always gain it is. So induced EMF will act same direction or opposite direction. Everybody, you will act opposite direction. Yes or no? Please respond. Yes. Nobody answers. Clear, guys?
Yes, sir.
That is it. So now you all of you see, we all knows that. So what is the induced EMF, which is equals to? Just now we have discussed the formula. What is the induced by using a Paradise laws? Delta V or E is equals to, speak loudly, guys, mod of L into di by dt. Do you all remember, everybody? Yes, please. Nobody answers. Induced EMF, induced EMF is equals to L into di by dt. Just now we studied card. Yes or no? No. Di by dt, mod of. Yes.
Yes,
So
sir.
now, if you all notice it here, everybody observe very carefully. So here I will apply the Kirchhoff's laws. So apply the Kirchhoff's laws. We all know closed loop. Kirchhoff's laws, all of you remember? Kirchhoff's laws, everybody? So I'm applying the closed
Yes, sir.
loop. So this is what it is. Closed loop. So closed loop, all of you write it. Apply. Yes, brothers. Now all of you understand? Kirchhoff's laws. So KVLs. So if you apply the Kirchhoff's laws, closed loop, all of you see. So battery always from where to where? Negative to positive. So negative to positive, this is the direction of path. So it is what? Positive or negative or? Negative to gain, guys.
Positive.
Positive to negative, gain.
Pass.
For resistor, this is the current. Understanding? So this is the path. So what? Negative or positive or? R is equals to, sorry, I is equals to,
Negative.
RV is equals to.
Negative.
So it is minus IR. Minus IR. All of you remember? I want answer. Yes?
Yes.
Yes. Same way. Now this is the current induced in the induced, that is what? Inductor. This is the direction of current. Means this is the positive and this is the negative. Will all agree with me? Yes or no? Speak loudly. Nobody answers. Yes, it is moving. Sorry. It is moving from here to here.
Okay.
So which is positive, which is negative? It is going from here. So what is positive, what is negative? So this is the positive. It is opposing current. So this is the positive and this is what, everyone? It is, speak loudly. It is positive and this is what? Negative. Yes or no, guys? Because current is coming in this direction.
Yes,
And induced one, it is going like this. So always it will go from positive to negative, opposition. So it is what? Negative or positive or? Induced EMF. Minus. Yes or no? Positive to negative, correct. So loss of minus or plus or minus. Yes or no, guys? So by applying the Kirchhoff laws, you can see it is going from, because we have to come in a what? Anti-clockwise. Now here, negative to positive. Gain or loss of? Gain or loss? Gain. Correct, ama? Anti-clockwise, ra? Nobody answers. Path
Yes.
this only, yeah. So negative to positive, same direction. So gain or loss? Everybody should respond. Gain. So positive or negative? Positive. E. Next. Coming. So that it is acting in this direction. Induced EMF is acting in this direction. Induced current is acting in this direction, but the circuit is going anti-clockwise. So this is positive to negative. So negative to positive, but it is acting opposite. So it is also what? Minus or plus or? Minus. Opposite it is acting. So what is that, everybody? Minus L di by dt. Are you clear now? I want answer. Everybody. Now, this is the direction of I. For those understanding? And this is a resistor. So what is going to happen, everybody, now? This is the direction of I and this is the path. So what will happen, everybody? Positive or negative? Minus? Nobody answer. Induced EMF. Kirchhoff's laws, KVL. Minus.
IR.
Here also written, it is, see that this is the direction of I and this is what R. So what is that path is that? Negative or positive? Negative. Am I right, guys?
Negative.
Which is equals to 0. Now, so from this, all of you see that. Can I write this one as E minus IR, which is equals to, this minus will come this side. It will become L di by dt. It will hear any doubt, anybody can ask me. All of you clear? Yes, everybody? Nobody answers.
Yes, sir.
Yes,
Yes, sir.
if we consider this whole term is a single one. So dtL, you will bring this side. So I'll write it as a dt by L, which is equals to di by E minus IR. Will you all agree with me? Can I write it or wrong? Yes, please. Everybody? So I will apply the limits. So time t equals to 0 to time t equals to t. So by the time, when time t equals to 0, current is equals to also 0. When time becomes t, current also becomes what? Speak. Time t, not infinity. Current also becomes what? I. Nobody answers. Yes or no, Ra? Yes, that is what. So L is constant. So integral dt. So what is the integral dt formula? Integration of dx.
T.
Integration of dx is what?
X.
Integration of dx x. So integration of dt is t. So it will become t by L. Will you all agree with me? I want answer. Yes or no? That is what. So same way. This is looks like integral dx divided by b minus ax. See that exactly. So what is the formula? Integral dx divided by b minus ax. Long back we studied. Anybody can tell? Log b minus ax. Log b minus ax divided by minus a. All of you remember formula? Not remembering, I cannot do anything. Yes, brothers, at least remember this formula. Minus integral dx, everybody. Yes, same way you tell me this formula now. What will happen this one? Which will become log base e b minus ax. So what is the b minus ax here? E minus IR divided by minus a. So minus r. This is what. Any doubt, anybody till here you can ask me. So integration 0 to I. Is it okay, guys? Limit. Speak. If you speak only, correct it is. That is what. Now, this minus r is in constant, will bring this side, it will become minus RT by L, which is equals to log base E. So substitution, which is equals to E minus IR minus of log base E minus 0. If I substitute, it will become into E. Is it okay, Ra? You all respond, Ra. What is this life, right?
Yes, sir.
So this will
Yes, sir.
become minus RT by L. Now this also, shall I need to beg you people? You can easily respond and tell me. Now log A minus log B, which is equals to what? Log A minus log B, which is equals to what? Everybody. Log
A by
log A by B. Finish. Now log will come this side. It will become what? Exponential. Yes or no? Speak loudly. So log E base E by E 1. 1 minus IR by E. I can write it. Any problem? So which is equals to minus RT by L. So log will come this side. It will become what? Power. So I will write 1 minus IR by E, which is equals to E power minus R by L into T. Will you all agree with me? I want answer.
Yes, sir.
Finish. Now all of you check it, everyone. So now what I will do, I will bring this side positive and this building I will bring negative. So I'll write 1 minus e power minus r by L into T, which is equals to IR by E. So I want it now I. So now we all know R by E is equals to something. Anybody can tell what is R by E equals to? Already we studied today only. R by E is equals to something. Check it, everyone. R by E not, E by R. Sorry, it is reverse correct. Oh yeah, it will be coming this side. So let me write it now. Next step. So I is equals to E by R into 1 minus E power minus R by L into T. So E by R equals to something, guys. What we studied? E by R is equals to E maximum. That is what? I naught. Yes or no? Yes, that is what. So I is equals to I naught into 1 minus E minus. So R by L is remains constant. Let me assume that constant is tau. So tau means inductive time constant. What is that? Inductive? Yes, inductive time constant. So means can I write as a R by L? Okay, sorry. L by R is inductive time constant. So now we have R by L. So it will become what, everybody? So all of you note that, everybody. So L by R is call it as inductive time constant. But here we have R by L. So means it will turn up into what? Tau or 1 by tau? Everybody. Yes, please. Arey yaar, L by R is equals to tau, inductive time constant. But we have here R by L, means it will become what? Tau or 1 by tau? 1 by tau. Understand?
by
So which is equals to, I is equals to I naught into 1 minus, understanding? 1 minus of T by tau. Will you all agree with me? Everybody, I want answer, please. All of you?
Yes, sir.
Yes. So this is only the formula, growth formula. So growth from 0 to maximum of a current, this is what is the formula. So please remember. Any doubt? Anybody can ask me. All of you okay, guys? Yes, please.
Yes, sir.
So please do it. Mr. Rudresh, understand? Pradosh? Mr. Narayan? Sai? Rinsi? Any doubt? Ask me.
Yes, sir.
Yeah. Clear? Any doubt, Pradosh? No answer. Others, everybody, Mr. Rahul? Any doubt? I want answer. Respond, please. Clear or not?
Yes, sir.
Okay. So now, can you tell me when it will become maximum? So let Karvan, what is tau, sir? Define tau now. So what is tau? So let us see that. So let me consider now time tau, time, this constant, inductive time constant, t become tau, then what will happen? I is equals to, speak loudly, I naught into 1 minus e power tau by tau. So tau by tau means it will become cancel, it will become 1. So I is equals to I naught into 1 minus e power minus 1. So can you tell me e power minus 1 means 1 by e. 1 by e value how much? 1 by e value, 1 by e value. Nobody knows. Without knowing 0.1 by e value. 0.37. Yes, Pradosh, never studied. I never taught. I taught you already. So I is equals to I naught into 1 minus 0.37. So which is equals to what? Meeting is going to end. Join everybody. I want to see. 1 minus 0.37, which is equals to what? 0.63. So I is equals to 0.63 times of I naught. So when it will attain the maximum, where t equals to t, how much it is? 0.63 means what percentage it is of total? Of what percentage of total it is? Nobody answers. 63% of total current it will reach us to, that is what. So because we cannot attain the maximum infinity, everybody is the same it will be. So this is what meeting is going to end.